So let's look at a review of some of the properties we've seen of the Fourier transform. So here are the Fourier transform pairs up here. Now this is the forward transform going from the time domain to the frequency domain, and the inverse transform going from the frequency domain back to the time domain. We've seen the linearity. We've also seen the idea of scaling. So if we multiply a function by a factor of a, it's equivalent in the time domain of dividing by the modulus of a, and you get the original Fourier transform of the function divided by that factor of a. And the same holds true whenever we adjust a stretch or compress a function in the frequency domain. We get 1 upon the modulus of b in the time domain divided by b. We also looked at the duality property. So if we take the Fourier transform of a function and then take the Fourier transform again, it's equivalent to multiplying by 2 pi, and the time gets inversed or negated. We've seen the shifting property as well. If we were to take a function of time and we were to delay it by a value of t0, it's equivalent in the frequency domain of looking at the original Fourier transform and adding linear phase onto it. And we also seen it whenever we did this in the frequency domain as well. It's equivalent to adding linear phase in the time domain. We then looked at convolution. So convolution in the time domain was equivalent to multiplication in the frequency domain, and also multiplication in the time domain was equivalent to convolution in the frequency domain, and it was changed by a factor of 1 upon 2 pi in this case. We've also seen differentiation in the time domain is equivalent to our multiplication by a factor of omega in the frequency domain. And we've also seen integration. If we were to integrate a function between minus infinity to a factor of t of f of t, is equivalent to division by I omega. And we had a constant of integration here. We looked at the cosine and the sine functions as well, and that gave us our two impulse functions separated by plus omega naught and minus omega naught. And then we looked at a shifted impulse. So if we were to look at a function f of t and we were to shift it in the time domain by t0, it's equivalent to taking the impulse function and convolving it with the function f of t, and we also seen that in the frequency domain as well. So this is not all of the properties of the Fourier transform, but some of the main properties that you tend to see. So that's all for this video. Thank you for listening, and goodbye.